Yes, sir, we are live. Just Kushagra, sir, just start with the.
अच्छा, इसको मैं स्टॉप शेयर कैसे
Sir,
करूंगा
sir,
बाद में?
sir, sir, we are live. Kushagra, sir, you just start with the introduction. You'll see rest thing again. Like after the.
Okay.
You just start with the introduction.
Okay. So, are we live now?
Yeah, we are live.
Okay. You just do one thing. Just share it. And then we'll start. Okay.
That we will do. You just start the session now.
Okay. So, good afternoon to all attending this live session. In this session, we'll be talking about the most general doubt a student have after attempting JEE Witset Comet Key and other entrance test, and they move towards engineering. That what is the more innovative way that we can achieve engineering degrees and all. For these questions today, we have with us Dr. Sanjay Goyal sir, who is the director of Institute of Engineering and Technology at JK Lakshmipat University, an alumnus of BITS Pilani and IIT Delhi. Dr. Sanjay Goyal is currently the director of the Institute of the Engineering and Technology at JKLU. He is actively engaged in developing, demonstrating, and leading new models of engineering education as a progressive researcher and educationist. Through an illustrious 35 years of professional experience, we welcome you, sir, to the live session and would be grateful if you take doubts of our viewers and give them a big side for their career. Over to you, sir.
Thank you, Kushal. Thank you. So, good evening, everybody out here. I hope you people are preparing well for your JEE Advance. You have already given that. The result is awaited now. Yeah. So, today I will discuss what kind of possibilities exist for you after doing a good engineering education and how in today's times engineering education has become very interesting at some places. I am assisted by my team here. 4 colleagues from computer science, electronics, mechanical and maths department are helping me here. They will demonstrate after some time how in some interesting way engineering education can be done in a very, very exciting manner. Okay, and we will show what kind of work the students have done in the first year itself. Okay, so before that, let me look at the larger context. The title of the talk that has been kept for today is Innovative Engineering Education for the 21st Century. Now, what is the characteristic of the 21st century? First of all, in the next slide, in a very brief manner, I try to give you the picture of the 21st century, what is happening, what are the interesting things that are happening in 21st century. So 21st century is actually characterized from the technology point of view. I'm just talking only technology and business point of view. I'm not talking from the social point of view, not the political point of view. I'm only talking from the technology and business point of view. Business point of view also limited to technology related businesses and the opportunities for the technological businesses. That's what I am focusing on. Okay, so the 21st century is we can say is a combination of 3 things. I have one slide which is first of it is that in 21st century we have entered the era of zettabyte. Zettabyte is billion trillion, 10 is power 21 bytes. So we are generating a lot of data every moment now. Every moment we are generating a lot of data. So much data has never been seen by anybody. And the rate at which this growth of data is increasing is phenomenal. It is expected that by 2025, we will, or by 2030, we will have we will be generating around more than 500 zettabytes of data. And by 2050, when you are at the peak of your career, there will be 50,000 to 5 lakh zettabytes of data. That is very huge amount of data. And this data is actually coming from a variety of places. This is coming from factories, this is coming from railway stations, this is coming from warehouses, this is coming from banks, insurance companies, social media, this is coming from OTT platforms, this is coming from your Twitter, Instagram, and this data is coming from everywhere. From the government services, from the citizen services, this data is coming from everywhere. Okay, so I will limit it to that. The other thing that is happening is the industry 4.0. Okay, which is a fusion of three kind of words: physical world, IT, the digital world, and the biological world. So 21st century will see a lot of fusion of these three otherwise different words. Till now, the development that was taking place was in silo. The biological developments were taking place in one domain, the IT developments were taking place in another domain, and the physical developments were taking place in another domain. 21st century is going to see a fusion of these. Okay, and that's why this data will be generated from biological systems, will be generated from physical systems, and would be processed on the cloud, on the edge, and AI will help in taking some smart decisions. Virtual reality will help in taking smart decisions. Augmented reality will help in taking some smart decisions and saving money, increasing productivity, increasing efficiency in all sectors. Whether it is manufacturing, whether it is logistics, whether it is banking, whether it is insurance, education, whatever. Okay, so so you have some few data points that I want to share here in this regard, that what kind of future is being projected. So here is a future of jobs report by World Economic Forum, which said robotics and industrial automation are likely to be adopted by 60% of the companies globally. That's a huge number of companies. So robotics and industrial automation is going to be very, very commonly adopted, and there is a huge opportunity in India also for that, with respect to companies in India as well as companies overseas. Okay, because India is a global manpower supplier of the technical manpower, and there is a huge opportunity, and we do take a lot of contracts from various countries to actually develop their technologies. And there is a lot of R&D taking place in India for a variety of purposes for different companies. There are a lot of R&D centers in India. They are serving the global markets. So there is a huge opportunity for motivated young engineers to really work in this area. Here is another data point. McKinsey's 21 report. 70% of the respondents of their survey said that their companies are planning automation to be introduced in one of the business units immediately. Okay, that's another very, very exciting data for those who want to get into technology. Okay, and another important point in this report is smart factories by 2025 will generate $37 trillion of products. So smart factory is where you have machines making things, you have computers controlling them, you have internet connected to it, you have Internet of Things connected to the machines and then monitoring them and seeing the quality. And so there is a lot of automation in smart factories, a lot of software, a lot of hardware, a lot of mechanical engineering, a lot of electronics engineering, a lot of computer engineering, all put together. Okay. Another interesting survey is the warehouse market, the Godam jisko kehte hain, right? So the warehouse automation market is going to expand nearly 4 times very soon within next decade. Within this decade, it is going to expand hugely. So the warehouses are going to be automated in a big way. There are already companies that specialize in warehouse automation, and India has a great opportunity in that regard too, for Indian warehouses as well as overseas warehouses. IoT market is going to be by 2029, $2.5 trillion. That's huge. That's almost like Indian economy size at the moment. So the total size of the Indian economy, that much will be the global IoT market by 2029. Okay. And industrial IoT out of this, which will be the IoT applied within the factories, within the manufacturing sector, warehouse sector, etc., will be nearly half the India's economy at this point. That's a global market for the industrial IoT market. So what I'm saying from this data point, what we see from this data point is you have huge opportunity for all kind of engineers. Only thing is they should be able to integrate physical world with the digital world, or the biological world with the digital world, or all the three put together. Okay, the people who are able to do this would have an opportunity to participate in very rapidly growing markets and contribute to the technologies there, contribute to the solutions for the customers there. Okay, and what is the impact of this on jobs for engineers? These are some other data points. What is happening to the jobs for engineers? in May itself, in US, for example, more than 6 lakh jobs were posted for the technology in the technology sector. Okay, in this year itself. This is one country, 1 month. Now look at the global scenario. This will be much larger than that. India IT services created 5 lakhs new jobs in financial year 21-22. Okay, and that's the Economic Times news of 11th May. Okay, IT led the way by creating 2 lakh new jobs during 21-22. Okay, so and this was followed by banking, etc. Okay, between April 20 and June 22, the 5 IT companies, they increased their headcount by 36%. More than 4 lakh employees were added by these 5 companies during the COVID period. During the COVID period, they increased their strength by 36%. And here are some postings on Naukri.com in just around 10-15 days ago. For different sectors. Software, so many lakhs of jobs. Telecommunications, so many thousands of jobs. Data science, so many thousands of jobs. VLSI, so many thousands of jobs, etc. And in VLSI, Union Cabinet has approved a comprehensive plan to support the semiconductor and display system ecosystem in the country by creating a huge outlay of around 75,000 crore for that. So this sector is going to see a lot of growth. So what we saw in the previous slide was the way the economy is going and the way the fusion of the technology is moving, and how and what will be happening to the size of the economy, size of the market in those sectors, and because of that increase, what is happening to the jobs for engineers in India. These are some data points on that. Here are some more data points. Yeah.
Sorry, sir. Sorry to interrupt, but I would like to ask one question, which is the most asked question right now. मतलब अभी काउंसलिंग वगैरह चल रही है, तो बच्चों के माइंड में और पेरेंट्स के माइंड में सबसे ज्यादा जो डाउट आता है वो यही आता है कि ठीक है, कंप्यूटर साइंस सबको चाहिए. आज की डेट में कंप्यूटर साइंस जो है वो ट्रेंड पे चल रही है, इसलिए सब लोगों को कंप्यूटर साइंस चाहिए, वो भी अच्छे कॉलेजेस के अंदर. उसके अलावा वो लोग ये पूछते हैं कि कंप्यूटर साइंस के अलावा ऐसी कौन सी डिपार्टमेंट्स हैं, ऐसी कौन सी ब्रांचेस हैं जो कि फ्यूचर में हमको अच्छे प्लेसमेंट दिलवा सकती है, क्योंकि हर किसी को तो कंप्यूटर साइंस मिलेगा नहीं. तो इसके अलावा
मिल भी जाएगा तो लेना नहीं चाहिए. What I would say is, अगर मिल भी जाए तो हर किसी को नहीं लेना चाहिए, because you look at these job postings on Naukri.com, look at these job postings, and the previous slide, I again go back to this previous slide, look at this. Robotics and industrial automation is likely to be adopted by 60% of the companies. The smart factory market is going to expand like anything, तो इसमें क्या है, what is important now is at least the 2 words out of the 3 words. There is a physical word जिसमें ये mechanical, civil आता है, okay, या electrical आता है. There is this digital word, that is software, and then there is this biological word. The current era is of fusion of these two. Okay. So computer science as a standalone discipline is okay, that is going to give you a lot of jobs. But computer science, when embedded in any of the other disciplines, it gives a cutting edge. It gives a cutting edge. So if you know manufacturing technology, along with how IoT, how robotics, how automation, and if you know CAD, etc., CAD, CAM, IoT, robotics, etc., then you get a cutting edge and doing this smart automation in big manufacturing facilities. The factory of today and tomorrow are going to be very, very different from the factories of yesterday. There is a lot of automation in the factories. So the students who are who enjoy working with physical objects should actually, in my opinion, go for mechanical engineering, but in a very, very selective manner. Go to that university which gives you a good dose in electronics and computer science, also along with good dose in mechanical engineering, so that you can play a very active role in building robots tomorrow.
जैसे मान लो 70 कॉलेज है, तो 70 के 70 कॉलेज तो आप भर नहीं सकते. मान लो आपकी रैंक पे 20 ही भरने हैं, ठीक है, तो आप वो 20 कॉलेज ही दोगे. आपकी रैंक पे कौन सा कॉलेज बेस्ट रहेगा, तो हमको लिस्ट बना के देते हैं हमारा वो काम. प्लस आपको जो भी डॉक्यूमेंट वगैरह चाहिए, काउंसलिंग रिगार्डिंग जो भी आपके डाउट है वो सब हम क्लियर करते हैं. बाकी लॉगिन करके अपने पोर्टल पे
kind of engineers who know physical as well as digital world. Okay, construction industry is going to see a lot of automation. Okay, so I would say pick up your branch because of your core
बाकी
interest,
हमारी काउंसलिंग
not
फीस
just because
450 आप
everybody
चाहो
is
तो
doing
रजिस्टर
computer
कर
science.
सकते हो.
I'm a professor
कोई
of
भी आपको
computer science, and
काउंसलिंग
even
में
then I'm
पुरानी
saying so.
दिक्कत रहेगी तो हम
Okay,
उसमें
so
हेल्प करेंगे.
do not pick up your discipline just because everyone else is picking it up. If you are passionate about something, please
हाँ.
pick that as your area, but make sure that you know enough computer science, you know enough electronics to integrate that passion with these two so that you can create a digital world. Digital means physical and a digital world, a combination of these two.
Like, can you throw some light on this thing that you told that being in some other branch also you should know a limited amount of computer science so that you can get into something?
So not limited, good amount. Good amount means you should be good at programming. You should be good at programming. You should know IoT. You should know embedded systems. Okay, these are some minimal things that you should know data analysis. Okay. Because all engineers would be doing data analysis. You should be able to use computational tools for doing data analysis. You should be able to use electronics for doing some automation, and you should be able to integrate your physical things with the computer using electronics, and then capture the data, process the data on the computer, and then take some decision using AI on the computer, do some machine learning, and then send the command back to the machine to do that. So no data science, no little bit of machine learning, no IoT. These are the things that I would recommend all engineers of today should learn. Okay, and then if you are doing mechanical engineering, you should know CAD, you should know CAM, and you should know good production technologies, you should know good design practices, and then future is very bright, because as long as humans live, I often say, as long as humans live on this earth in their body, they need physical things, right? The moment they wake up, they need some physical thing, and in order to sleep, they need a physical thing. We move with physical thing. We live in a physical environment, which is populated by physical objects. Those physical objects are becoming smart, IT enabled, internet enabled, IoT enabled. That is what is happening. I mean, I can just give an analogy. पुराने जमाने में हमारे कल्चर में एक बिलीव है कि पंच तत्व, आकाश, धरती, वायु, अग्नि, और what is the fifth one, so these panch tattva create the srishti. Okay, that's the belief. What has happened is, in addition to these 5 elements, you now also have this software which is integrated with everything, and that is the beauty of the new 21st century. So all the objects, your spectacle, your wall, your almirah, your shoes, your clothes will become data generators. So you got to. So if you enjoy making machines, please do make machines, but make machines that are smart. That have. So for example, we teach a course of mechanisms to our third year computer science students. It's a mechanical engineering and electronics engineering faculty together teach this elective course, where mechanical movements are taught along with how different sensors can be put there, so that machines that are made can generate data for the computer to process. Okay, so do not just blindly join computer science as a discipline. You choose, if you are interested in cars, if you are interested in machines, if you are interested in robots, join other disciplines, but make sure that, like all engineers need to know mathematics well, today all engineers need to know a good amount of computer science, which includes programming, which includes IoT, which includes machine learning, which includes a few other things. But these are some minimal things that they should know. Data analysis. These are, if you know this and then put it in the context of your main engineering subject, you are a star. You are a star, really, because physical world and physical industry has to grow with that kind of people. Okay, so these are some jobs. I'll skip on these 2 slides. This is some US data. Look at this.
Excuse me, sir.
Look at the job opportunities that are there in US for civil engineers, industrial engineers. Yeah.
Sir, there is a doubt in live chat, like what's the future of branches like civil, metallurgy and biotech? Like if they are not interested in computer science and coding and all the tedious work, then what is the scope for those students?
I would say coding is something that is now an essential skill, almost like it is like saying, what is the future for civil engineer if they don't like mathematics? Okay, it is like that, because you can't even learn civil engineering without mathematics. You need to do a lot of mathematics to learn civil engineering. Similarly, today, in order to learn civil engineering well, you need to be good at programming. Many tasks that the teachers in civil engineering in an advanced institute like ours will give would require you to do some programming. There is a lot of CAD in civil engineering. There is a lot of automation in civil engineering. All that would be done better in collaboration with civil engineers who understand programming. Okay, so those kind of that deadly combination, civil engineering and this IT, which includes IoT, etc., programming, gives you a cutting edge within the civil engineering community, and you become a star there. That is what I am saying. Okay, so if you are interested in a core in some area, please try to go for that core area. Okay, because there will be a lot of opportunities in all core areas. Industry will grow multidimensionally, not in a unidirectional manner. That is first thing. Okay, and then you would possibly be a very special professional. Very few of that type would be there. Okay, but you should not run away from programming. You should learn basic programming. You should learn using IoTs to capture data and then control some machines. Okay, you should learn data analysis. So that is what I would say. Today's all engineers must learn programming. Very, very important. They should learn other things, but they must also learn programming. That is essential now. Okay, I will skip on this. You see, in data science, what kind of jobs are opening? Millions of jobs are projected. These are some technologies that have been projected by the World Economic Forum to be adopted by different companies. Many of them are IT technologies, but there are other mechanical technologies like 3D and 4D printing. That's very, very important. Power storage. Energy is becoming a big sector. Batteries are, innovative batteries that will store a lot of energy, that will last much longer. Very, very important. We need new materials. So metallurgy people are very rightly trained for doing new materials. So a lot of new technology will happen because of new materials. Okay, there are projections that human organs will be printed by 3D printing. Okay, so that's a fusion of the biotechnology and computer science and mechanical engineering. Okay, mechanical engineers are studying biomechanics these days, how to make cars safer. So they study using computer simulation how the human body behaves and how it behaves in the event of an accident and what goes wrong and how to make the car safer for that. A lot of studies are going from that. Mechanical engineers study the behavior of various animals, how bat, for example, flies. And then from that, creating a model, and then maybe can we create a robot that mimics the way the bat flies. So this is physical, biological, and digital, all word put in an integrated manner. So I would say identify your passion. Do not be so worried that you are in 12th class, you are so much worried about the job. Do not get so much worried about the job. If you pick up a discipline and do very well there, I promise there are ample number of opportunities across the world for you if you know any subject very well and if you are a master of any subject. The world is much more multidimensional than anybody can think. Okay.
Sir, one more thing. जैसा कि आप जानते हैं, हमारे जो व्यूअर्स हैं वो मोस्टली अभी वो बच्चे हैं जो कि 11th और 12th क्लास क्लियर करके या 13th क्लास करके अभी जेईई के बाद कॉलेज में जाने वाले.
बिल्कुल.
तो अभी तो आपने जो एक चीज बोली कि ये गुड अमाउंट ऑफ कंप्यूटर नॉलेज होनी चाहिए, आप चाहे इरिस्पेक्टिव किसी भी ब्रांच में जा रहे हो.
बिल्कुल.
तो कुछ ऐसे कोर्सेज हैं या कुछ ऐसे पर्टिकुलर लैंग्वेज या प्रोग्रामिंग लैंग्वेज जो कि आप रिकमेंड करोगे कि ठीक है अभी से आप कॉलेज में नहीं भी हो तो पहले से थोड़ा सा उसको सीखना चालू कर दो?
नहीं, कॉलेज से पहले से सीखने की अभी कोई जरूरत नहीं है. अभी तो कॉलेज का एडमिशन लो, अच्छा कॉलेज चलो, कॉलेज में जाओ, कॉलेज में रहते हुए सीखो. अच्छा, देखो लैंग्वेजेस का किया है कि लैंग्वेजेस हर 5-6 साल में नई नई लैंग्वेजेस ज्यादा पॉपुलर हो जाती हैं. आजकल इंडस्ट्री में जो दूसरे जो पाइथन बहुत पॉपुलर है आजकल. ओके, जो कंप्यूटर साइंस में भी पॉपुलर है और जो दूसरे इंजीनियर लोग हैं वो भी बड़ी आसानी से इसको सीख सकते हैं. इट इज मच इजियर देन सी फॉर एग्जांपल. ओके, तो है ना, या पास्कल जो होती थी बहुत पहले, इट इज इजियर देन दैट. तो पाइथन सीखना इतना मुश्किल नहीं होता है। हम अपने वहां फर्स्ट सेमेस्टर में सारे बच्चों को पाइथन सिखाते हैं ठीक से। ओके, तो दैट्स वेरी इंपॉर्टेंट। मैंने बोला अपने ओपनिंग रिमार्क्स में, इट इज गुड फॉर एनी इंजीनियर टू नो few basic computing technologies. One is programming, preferably Python at least. Okay, Java भी आ जाए तो बहुत अच्छी बात है, but Python at least is minimum for other computer for other than computer science. I'm making this statement. Okay, computer science में तो बहुत चीजें सीखनी होगी, but for mechanical, civil, electrical, learn Python in a good manner. Learn IoT very well. IoT is very very important these days, है ना? The world is going to be embedded with IoTs everywhere. आपकी कुर्सी, मेज, दीवार, चश्मा, आपका टॉयलेट, इन सब चीजों में IoT लगने वाले हैं। और फैक्ट्रीज में तो IoT बहुत जबरदस्त तरह से लगने वाला है, गोदामों में IoT लगने वाला है, रोबोट्स में IoT बहुत लगता है। तो IoT को सीखना बहुत इंपॉर्टेंट है कि कैसे फिजिकल वर्ल्ड से डेटा को कैप्चर किया जाए, उस डेटा को फिर कैसे कंप्यूटर में डाला जाए, फिर कंप्यूटर में उसको प्रोसेस करने के लिए आपको एल्गोरिदम जानना चाहिए, प्रोग्रामिंग आनी चाहिए कम से कम। और अगर आप मशीन लर्निंग या AI भी सीख लें तो दैट्स लाइक सोने पे सुहागा। ओके,
एक चार्ट में क्वेश्चन है कि मेटलर्जी ब्रांच लेकर टेक कंपनीज में जॉब नहीं मिलती क्या?
देखो, अगर आप ग्लोबल मार्केट देखोगे तो ऐसा नहीं है। देखो, एक है, सी आई वुड से youngsters, please plan to be a global citizen. Do not see the today's India's market as your limiting condition. Expand yourself. Expand yourself. तो बहुत सारी चीजें जो
नहीं सर, बच्चों को डर ये लगता है कि बहुत क्वेश्चन हमसे पूछे जाते हैं कि सिविल में है या फिर बायोटेक में है या मेटलर्जी अगर ले ली तो इसके बाद IT कंपनीज अलाउ नहीं करती हैं कि तुम अपने हमारे प्लेसमेंट्स में आके बैठो।
देखो
यार, I am completely in a live session on YouTube,
करती है, ठीक है? बहुत सारा काम जो TCS में, इन्फोसिस वगैरह में होता है वो मैकेनिकल इंजीनियरिंग से रिलेटेड होता है या सिविल इंजीनियरिंग से रिलेटेड होता है। और अगर ऐसा बच्चा हो जिसको सिविल इंजीनियरिंग भी अच्छी तरह से आती है और कंप्यूटर प्रोग्रामिंग और मशीन लर्निंग और IoT वगैरह भी आता है, वो तो एक स्पेशल एज लेके आ रहा है। क्योंकि देखो, ऑटोमेशन तो आप देख रहे हो ना, हर सेक्टर में हो रहा है। और वो ऑटोमेशन ये IT कंपनियां कर रही हैं, छोटी बड़ी स्टार्टअप, इंडिया की, ग्लोबल, राइट? तो ये जो ऑटोमेशन जो हो रहा है, चाहे वो कंस्ट्रक्शन में हो रहा है या मैन्युफैक्चरिंग में हो रहा है या हॉस्पिटल में हो रहा है, जहां पे भी ऑटोमेशन हो रहा है, और ऑटोमेशन सब जगह हो रहा है, सब जगह होगा। ओके, तो इस ऑटोमेशन को ठीक से करने के लिए आपको दो तरह की नॉलेज चाहिए। आपको IT की नॉलेज चाहिए और आपको डोमेन की नॉलेज चाहिए। तो डोमेन की नॉलेज के बिना खाली IT की नॉलेज कुछ नहीं कर सकता। ओके, तो ऐसे लोग जिनको डोमेन की भी नॉलेज है और IT का भी एक टूल की तरह से अच्छी तरह से इस्तेमाल करना आता है, उनको तो एक स्पेशल एज है। तो जो बच्चों को जॉब वगैरह की परेशानी हो रही है, वो वैसे वाले बच्चे हैं जिनको IT वाला टूल वाला सेक्टर जिनका वीक है, जिन्होंने प्रोग्रामिंग करी नहीं, ये सोचते थे कि हम तो सिविल इंजीनियरिंग के हम प्रोग्रामिंग नहीं करेंगे, या हम तो मैकेनिकल इंजीनियरिंग के हम प्रोग्रामिंग नहीं करेंगे, हमें IoT से क्या लेना देना, उनको चैलेंज है। ओके, लेकिन अगर बच्चा ऐसा है जिसने दोनों डिसिप्लिन को ठीक से पकड़ लिया है, उसको तो कंप्यूटर साइंस वाले से बेटर भी मिल सकता है, क्योंकि वो तो एक स्पेशल ब्रीड हो गया ना, है ना? सो दैट इज व्हाट इज टू बी अंडरस्टैंड। अपने पैशन के साथ कंप्रोमाइज करके अपनी लाइफ को डिस्ट्रॉय मत करो। दैट इज व्हाट आई वुड रिकमेंड। यू लिव ओनली वंस। इसको जरा अच्छी तरह से जियो, अपने पैशन को फॉलो करते हुए जियो, और उसके अंदर जो करंट टेक्नोलॉजिकल ट्रेंड है उसको एम्बेड करना है, बस ये करना है। डू नॉट बी अफ्रेड ऑफ प्रोग्रामिंग। इट इज नॉट डिफिकल्ट टू लर्न, इजी है, छोटे बच्चे कर लेते हैं। आप लोग तो मैथमेटिक्स इतना अच्छा करते हो, तो फिर प्रोग्रामिंग सीखने में क्या मुश्किल है? कोई मुश्किल नहीं है। थोड़ी सा पेशेंस के साथ प्रैक्टिस करने की जरूरत है, दैट्स इट। ओके, तो ये कुछ रिपोर्ट है कि फ्यूचर ऑफ जॉब में, कि अभी आने वाले टाइम में 25 के लिए क्या स्किल चाहिएगी। इसमें टॉप पे एक स्किल लिखी हुई है, इनोवेशन। जो ग्रेजुएट्स हो, जो इंजीनियर्स हो, उनको इनोवेशन अच्छी तरह से आना चाहिए। ये एक रिपोर्ट है। ये एक दूसरी रिपोर्ट है, ये मैकिन्से की रिपोर्ट है कि भाई कोविड के बाद का जो इंडिया है, इसमें क्या स्किल्स हैं जो सबसे ज्यादा इंपॉर्टेंट होंगी सबके लिए। तो देखो, एडवांस IT स्किल्स, प्रोग्रामिंग सबके लिए इंपॉर्टेंट है, साइंटिफिक रिसर्च सबके लिए इंपॉर्टेंट है। ओके, एक बीच में आती है क्रिएटिविटी। ये बड़ी इंपॉर्टेंट स्किल हो गई है। पुराने जमाने में क्या होता था, आप जैसे काम होता है उसको सीख लो और उसको उस तरह से करते जाओ, आपकी जिंदगी आसानी से बीत जाती थी। अभी वैसा नहीं है, अभी बहुत तेजी से चेंज होता है. सो पीपल हु आर क्रिएटिव, पीपल हु कैन डू इनोवेशन आर हाई इन डिमांड. ओके, ये हमारी न्यू एजुकेशन पॉलिसी है. इट सेज students should be taught how to innovate, how to absorb new material in a novel and changing field. Education should be multidisciplinary and they should be made creative. This is what the new education policy says. Why is it saying so? Because the world is becoming, because industry 4.0 की वजह से पूरा वर्ल्ड जो है वो फ्यूजन की तरफ जा रहा है और इतनी तेजी से नए नए प्रोडक्ट्स और नए नए सर्विसेज आ रही हैं. उन सबको मैनेज करने के लिए, उन सबको डेवलप करने के लिए बहुत इनोवेटिव माइंडसेट चाहिए. ऐसा माइंडसेट चाहिए जो नए प्रोडक्ट सोच सके, नई सर्विसेज सोच सके. ओके, तो ये जो ट्रेनिंग है, इंजीनियरिंग की जो ट्रेनिंग है, वो जो कन्वेंशनल वाली ट्रेनिंग थी उससे नहीं होगा. ओके, अगर कन्वेंशनल मॉडल में जाते हो तो ये बहुत बड़ा रिस्क लोगे आप अपने साथ. तो ब्रांच भी पुरानी वाली हो गई और मॉडल भी पुराना हो गया, वो गड़बड़ हो जाएगा. आपको क्या करना है कि ब्रांच चाहे कुछ भी लो, मॉडल नया वाला होना चाहिए. एजुकेशन का मॉडल जो वो लोग यूज करते हैं वो नया होना चाहिए, सो दैट यू आर गिवन प्रैक्टिस टू इनोवेट राइट फ्रॉम द बिगिनिंग. फर्स्ट सेमेस्टर से ऐसा इनोवेशन का प्रैक्टिस हो जाना चाहिए, सो दैट यू आर मेकिंग थिंग्स राइट फ्रॉम द फर्स्ट सेमेस्टर. ऐसा नहीं कन्वेंशनल टाइम में कि अभी आप पढ़ लो, बाद में बनाना कुछ. इंजीनियरिंग इज अबाउट बिल्डिंग थिंग्स, राइट? एवरीबडी वुड एग्री टू दैट और नॉट? Engineering is about making things. Making new things is even more exciting. So students should choose a university very carefully. जाके देखो कि फर्स्ट ईयर में जो भी यूनिवर्सिटी आप चूज कर रहे हो, ब्रांड पे मत जाओ. अभी ब्रांड देखो ऐसा है, अभी हम एक वर्कशॉप अटेंड करके आ रहे हैं, उसमें वो मैनेजमेंट की एक वर्कशॉप थी, उसमें उसने एक डेटा दिखाया कि ये अगले 10 साल में जो अभी वर्ल्ड की टॉप 500 कंपनियां हैं, उनमें से 75% कंपनियां will be replaced by other companies. Okay, so there are companies, छोटी वाली कंपनियां अभी वर्ल्ड की टॉप 500 में नहीं है, लेकिन वो उनको रिप्लेस करेंगी जो अभी वर्ल्ड की 500 में हैं. क्यों रिप्लेस करेंगी? क्योंकि ये कंपनियां इनोवेशन करेंगी. These company will make new things, okay, and will be able to move up and replace the older companies. जो अभी किंग है वो रिप्लेस होंगे. पास्ट में भी ऐसा होता आया है, but that replacement rate was slower. अभी ये रिप्लेसमेंट रेट विल बी मच फास्टर. स्टार्टअप्स विल ग्रो वेरी रैपिडली. मेनी कंपनीज इन द मीडियम सेक्टर, मिडिल साइज कंपनीज विल ग्रो फास्ट इफ दे आर फास्ट एट इनोवेशन. इट इज नॉट द बिग विच विल विन द रेस, इट इज द इनोवेटिव विच विल विन द रेस. और वो इनोवेटिव कंपनी चूज करेगी ऐसे इंजीनियर जिन्होंने अपने 4 साल के बीटेक प्रोग्राम के अंदर इनोवेशन की प्रैक्टिस करी है, प्रोजेक्ट्स पर काम किया है. ओके, तो जो, क्योंकि इनोवेशन की स्किल धीरे धीरे डेवलप होती है, ऐसे सडनली नहीं आ जाती है. तो अगर आप फर्स्ट सेमेस्टर से कुछ बना रहे हो और कुछ बनाते हो तो कुछ सोचते हो कि इसमें नया क्या बनाऊं. जब बनाने का ही मौका नहीं मिलता तो सोचने का कहां से मेरे को मिलेगा कि इसमें नया क्या बनाऊं. सो इट इज वेरी इंपॉर्टेंट दैट यू पिक अप अ यूनिवर्सिटी जिसके अंदर आपको ये मौका मिले कि आप कुछ बनाओ और हर सेमेस्टर कुछ ना कुछ बनाओ. हर सेमेस्टर 1-2 चीज नहीं, 2-3 चीजें बनाओ कम से कम. Okay, and go on building things, go on designing things, go on building things. That's how you should do engineering education today, and that kind of engineering education will prepare you for a bright career irrespective of the branch you choose, I promise you. Okay, that is the crux that I want to tell you. And kuch aur sawal ho to bolo before we move on to my colleagues here to demonstrate how फर्स्ट ईयर में या सेकेंड ईयर के कोर्सेज में एक इनोवेटिव वे में इंजीनियरिंग को अप्लाई, इंजीनियरिंग की जो सब्जेक्ट नॉलेज है उसको यूज करके इंटरेस्टिंग चीजें बनाई जा सकती है बाय द स्टूडेंट्स. कुशाग्र, यू हैव सम क्वेश्चन?
नो सर, लाइक यही क्वेश्चंस थे जो कि अभी बेसिकली जो पेरेंट्स के क्वेश्चंस वगैरह आते हैं वो यही आते हैं कि जॉब अपॉर्चुनिटीज कैसी होंगी इन ब्रांचेस में. और फिर मोस्टली ये क्वेश्चन आते हैं कि हमको लोअर ब्रांचेस मिल रही हैं कॉलेजेस के अंदर, उनकी अपॉर्चुनिटी क्या है, हम आगे जाके क्या करेंगे उन ब्रांचेस के साथ. एक
तो ये वर्ड जो लोअर ब्रांच है ना, ये शब्द गलत है.
हाँ सर,
है ना? जो आज आपको लोअर लग रहा है वो आपको स्काई पे ले जा सकता है कल को तुम्हारे को. बिकॉज आप ये समझिए कि वर्ल्ड में ह्यूमंस की जो नीड है वो तो मल्टी डायमेंशनल होने वाली है ना. फूड सबको चाहिएगा, फूड टेक्नोलॉजी की जरूरत होगी, फूड टेक्नोलॉजी को बनाने के लिए मशीनों की जरूरत होगी, उन मशीनों को बनाने के लिए मैकेनिकल इंजीनियर की जरूरत होगी, उन मशीनों को चलाने के लिए इलेक्ट्रिसिटी की जरूरत होगी, इलेक्ट्रिसिटी को बनाने के लिए इलेक्ट्रिकल इंजीनियर की जरूरत होगी. तो वर्ल्ड इज मल्टी डायमेंशनल. तो अगर आप अपने सब्जेक्ट में माहिर हैं, दैट इज द क्रक्स. You are passionate about something, you learn that well, and not only do you know your core subject well, you also learn how to enrich your core subject with the knowledge of current IT trends, which are programming. आपको करना ही है, वो तो हमेशा से रहा है, and then you put it with the IoT and machine learning भी आ जाए, तो then it's all integrated, and then you can do very interesting things in your career, जो भी आपकी ब्रांच है, चाहे वो मेटलर्जी है, चाहे वो मैकेनिकल है, चाहे वो सिविल है. ओनली थिंग इज, मोर देन चूजिंग अ ब्रांच, इट इज मोर इंपॉर्टेंट कि आप ऐसा एजुकेशन सिस्टम चुने. वेरी वेरी इंपॉर्टेंट. आप ऐसा एजुकेशन सिस्टम चुने जो आपको इनोवेशन की और इंटीग्रेशन की ट्रेनिंग दे. ये जो इंटीग्रेशन की ट्रेनिंग है, ये बहुत इंपॉर्टेंट है, क्योंकि क्या होता है कि लोग पढ़ा देते हैं अलग अलग सब्जेक्ट, लेकिन आपस में उनको इंटीग्रेट कैसे करें ये नहीं सिखाते. तो जब वो नहीं सिखाते तो देन यू आर इन साइलोज, एंड वो समझ में नहीं आता कि क्या करें. उसको ठीक से समझने के लिए बहुत जरूरी है कि आप ऐसी यूनिवर्सिटी चूज करें जिसमें इन अलग अलग सब्जेक्ट्स को, अलग अलग डिसिप्लिन्स को इंटीग्रेट करना सिखाया जाए और करा जाए, यहाँ पर एक्टिवली करा जाए, और जहां पर इसको अच्छी तरह और उस इंटीग्रेशन के साथ कुछ इनोवेटिव प्रोडक्ट बनाने की रेगुलर प्रैक्टिस हो. वंस नहीं, रेगुलर प्रैक्टिस हो. और आपको ऐसा देखना चाहिए कि क्या इस यूनिवर्सिटी से मेरे को ऐसा मौका मिलेगा कि मैं दूसरी यूनिवर्सिटी में जाके सेमेस्टर स्पेंड कर सकूं, ये भी देखना चाहिए. ओके, क्या इस यूनिवर्सिटी के पास कुछ ऐसे टाइप्स हैं कि क्या मैं फॉरेन यूनिवर्सिटी में जा सकता हूं, क्या मैं आईआईटी में जा सकता हूं, क्या मैं IIIT में जा सकता हूं एक सेमेस्टर बिताने के लिए, सो दैट आई गेट एनरिच्ड, आई गेट मोर एक्सपीरियंस. क्या मेरे पास मूक्स को करने का अपॉर्चुनिटी है, क्या कोर्सेरा का मुझे अपॉर्चुनिटी मिलेगा कोर्सेरा के थ्रू कोर्स करने का. तो देयर आर मेनी फैक्टर्स दैट शुड लुक एट. ओके, that is what I am wanting to say. Not just कि कंप्यूटर साइंस ले लिया, because कंप्यूटर साइंस में भी you would find a lot number, majority of the computer science graduates of Indian engineering institutes are not good at programming, so even they don't get placed well. Okay, few stars make a crore rupees job or 2 crore rupees job or 50 lakh rupees job. Do not get misled by that. You be sure that it is not just entering into a discipline which will make you successful or bright. You will have to work hard whatever discipline you enter, learn it well, and be a superstar because of the ability that you develop. Using these 4 years for developing the abilities is much more important than picking up a branch. So pick up an environment pushes you to do interesting things. That's very very important, I would say. Okay. Yeah. So now I would request Dr. Ravi Shankar. Can you just start this? Okay, Dr. Ravi Shankar, can you share?
Yeah. Hello, everyone. This is Ravi Shankar Prasad here, and
so just take 4 or 5 minutes.
Yeah. Sure.
Yeah, just very quickly demonstrate how first year students have made some interesting things.
Yes.
And this kind of things can be done at any university if the university allows that to happen.
Yeah.
Okay.
Good evening, everyone. This is Ravi Shankar Prasad here from Department of Mechanical Engineering. In first year, we offer a course, Design and Prototyping, which is further converted into 2 modules, that is Design and Prototyping 1 in semester 1 and Design and Prototyping 2 in semester 2. Here, students get an opportunity to think innovative and convert their idea into real product. So a few activities which we give to students so that they can perform tasks and learn. These are some activities shown here. Then in session 1920, under a theme to develop a prototype that is a portable bicycle, a student learned to ideate a product. They ideated a product as a portable bicycle. They did freehand drawing, then made an AutoCAD drawing. You can see here, this is AutoCAD drawing. And then they converted into portable bicycle. which has been recognized by our ex-Prime Minister. And got good appreciation. Then here you can see a video journey where they made freehand sketch. Then they analyzed that. They started fabricating and again reanalyzing the system. Then you can see they are developing the product. They were evaluated by our faculty member and the product is ready. The product was demonstrated by students and we asked several questions and they were answered. They enjoyed writing their product. It was published in a paper and as mentioned, well appreciated by our ex-Prime Minister, Dr. Manmohan Singh. So this is also a glimpse. You can see there are so many different types of portable bicycle with different types of innovative joints they made actually. And it was done by our 1923 batch of students in session 1920. So,
and let me just add, these are not just mechanical engineering students. These are all branches. Students of all branches did it. Even computer science students were there.
Yes, sir, definitely. So now, in session 2021, student, because due to pandemic, they could not come to workshop. So there they, under the theme to provide a product as a solution for medical care system, they developed several medical care systems. Out of them, I'm showing it here, two are there. So Listen Me is one. So you can see here also, you can see first they made freehand sketch. This is a freehand sketch. Sorry. There was a freehand sketch, then they made automated drawing using AutoCAD, and then they developed 3D model using a software Onshape. And Listen Me is one product here we are showing, and there is a portable wheelchair cum stretcher. The few product video, they have made video also. You can see doctor's bag as an example. You can see a lot of mechanism they learned and they made this doctor bag as a functional product. These are battery where they can keep battery. These are the fasteners and these are joints. So after that they have made handrail also, and so that they can sanitize the handrail near escalators. So this is wheelchair cum stretcher, and this is again a kit to support medical care system. So these are the few, and in last session, that is the year 2021 and 22, the theme was agriculture based products. So there they made few projects. One is a scarecrow, another is crop cutter, dhan collector. There were almost 21 products they developed, different group of students. You can see here they have made first freehand sketch, then they have made AutoCAD drawing, then they have made 3D model using Onshape software, and finally they fabricated the real product, right, functional product. So out of this was almost 21 projects in this session also, and out of those, 3 are demonstrated here. One is a scarecrow, you can see here, and another is crop cutter, and another is dhan collector. You can see how close they were. Initially they thought about a product, and finally when they made a product, it was so close actually. So this was the ability of our students to think in a very accurate manner. So students were very happy, and it was really enjoying journey for students also. They liked it very much.
Okay, thank you, Ravi.
I think we'll stop here. Yes, sir.
Yeah, thank you. Can I get Devika now? Devika, can you please? Yeah, you can stop share, Ravi.
Yeah, definitely.
So I request you to please keep it limited to 5 minutes. Yeah.
Hello.
Yeah, Devika, are you able to? No, you are not
Ma'am,
audible.
you are mute. Ma'am, you are mute.
No, not audible.
Yeah, not audible.
So let's while she can try it later, we can move to other colleague. Santosh, can you try now?
Am I audible now?
Yes, you are.
Okay, thank you, sir. Let me share the slide.
Yeah, just share your slide and just keep it 5 minutes at the most.
Yes, sir. Is it visible?
Yes.
Okay, so this particular course is computational data analysis, and that is a 10 credit course. This was taught in very first semester, and this particular course is comprised of three subjects like linear algebra, probability statistics, and the Python programming. So every student has to, irrespective of their branch, every student has to go with this particular course, and our mathematics faculty will teach the linear algebra, probability, and statistics, and the computer science faculty teach the Python programming. So here you can see that the most of the concepts have been covered, and this particular course goes with multiple activities, like starting from the very first task, that what is the matrices and how what are the possible applications of that matrices. So this is one activity that goes under the algebra. So a student has to identify the types of matrices and how they can apply that particular matrix in various real life applications. So let me show you one particular activity that a student has done. Is this particular PDF is visible?
Yes.
Okay, so students have identified that the matrices can be used in cryptography, in computer graphics, in architecture, in video games and organizations. Even the real image is comprised of numerical values of the image intensity and the location. So that is a kind of matrix. So they have these are the activities done by the students. So that is the very basic activity, and that is the initial activity done by a student. And then after that, they have to model a particular data into matrices, like looking at the particular scenario that word problem is converted into matrix, and then they have to write some code for let's say addition of two matrices, multiplication, finding the ranking of a particular scenario. Okay, so in this particular case, the computer science faculty play the role to teach Python programming, like various kind of data types, control structures, decision statements, what are the various libraries that will help them into representing the particular data. Okay, so if you look at this particular activity, I'll just go quickly on this particular activity, that the graphs or the matrices. For that, they have to have the knowledge of NumPy library and the matrix operations. So matrix operations were covered in linear algebra, and this NumPy library in Python programming, we teach them how to use the numeric Python. So this is the numerical Python library. So they use this particular library to create matrices of different type, one-dimensional or two-dimensional or n-dimensional, and accordingly they can perform certain kind of operations on that. Okay, so that is one kind of activity with matrices. And then there comes another part, that encoding and decoding, like in cryptographic, like one earlier application was shown that cryptography is also one kind of application. So here we can encode and decode our text, like if some information is very important, we can secure that particular information by converting that particular information into unreadable format. Okay, so we have done kind of that activity also. Let me just show this. Okay. Okay, so here you can see that encoding, decoding text. like let's say this is a one-dimensional data, that is my name, and if I look at the ordinal value of S, that is going to return 83. So what I can do, I can check the ordinal value of each and every character, and then apply some arithmetic operation on that by shifting from this particular location to somewhere. So the new value, like here I have just subtracted 96 from each and every character value. So here you can see that the new values are something negative values, and now negative values cannot represent a character. Okay, so if I convert this into the character format, it is definitely different from the Santosh Verma. So no one can easily predict about the initial message. Okay, so by this way we can encode and decode the information into another unreadable format. So that is another. So a student will be able to model the complex problem and analyze that particular problem in terms of matrix and the Python libraries. Okay, then there comes another part. Okay, this is creating some issue.
Can you just complete in a minute, Santosh?
Yes, sir. Yes, sir. Actually, this is causing some problem. Yeah. Okay, so the projects, like students are able to do some projects, like we have selected some sustainable development goal, which is decided by UN Nation Assembly, and they are 17 in count. So our students are able to identify few of them, and accordingly they work on that particular goal. So they collect data sets from Kaggle or some renowned resources or WHO website. So they collect that particular data set and then analyze, apply some statistical method over there, some matrix operation on them to find the ranking of that particular data set, and accordingly predict something. Like in this particular project, our students were able to identify that how could we propose that a particular country can be declared as zero hunger country. Okay, so they estimate on the available cereals in their particular country, and they analyze other countries, what measures they do follow to, so that we can also propose that if a country has certain drawbacks or malnutrition, they can follow that particular guidelines, and accordingly they can improve on that. Another project, that water future in India. So as we know that only 3% or lesser than the 3% is drinking water. So what measures can we take so that we can have a good quality water, drinking water reserve for the future? Okay, so that kind of statistical analysis has been done in the. This is another project that students had done on gender inequality. So what is our evaluation plan here is, in this particular course, we assign some marks on assignment and Viva. So 5 marks each on Python, linear algebra, and stats. Like I have told you that 3 courses are there. So combined in this particular course. So every component is evaluated separately with the 5 marks. For assignment, quizzes are same, that 5 marks for each particular component. Then we conduct some lab evaluation, like we teach Python programming. So every Python program gets evaluated. Okay, so we use online platforms, some online judges like HackerRank or other similar platforms. So 20 marks is assigned over there. Small weightage is given to the theoretical exams, like you learn about linear algebra and statistics. So 20 marks weightage is given for the theory exam, and rest of the marks is having the project assessment. So each and every student has to participate in project in a particular group, decide a group by knowing the traits and features of other colleagues. So they have to create their team, and accordingly they have to select a particular theme from the SDG goal, and then they do work on particular project by applying these 3 concepts: Python programming to implement the particular concept of linear algebra, or stats to make a particular comment, like what they can do in near future. corresponding to the selected goal.
Okay, thank you. Can you just bring that evaluation slide? Can you just go back to evaluation slide one second? Yeah, keep that there. So, students, this is very important. In all our courses, we give a lot of emphasis, and you can see that it is not really heavily tilted towards theory exam. You know, there is theory exam because theory exams are very, very important. We cannot undermine them. But theory exam is not the only way to assess. This is very, very different from most of the universities in the country. And this is what the NEP also suggests. So pick up a university where you are assessed on doing the projects, assignments, report writing, those kind of education system. If a university has not modernized its education system, irrespective of the branch you get there, your experience will not be so exciting. You will not be, so you will do project if there are marks for the project, right? So that is what is very, very important. So now I would, so I don't think we will need to show that in other courses, because this is the typical model that we follow. And now I request Devika to, maybe Devika, you now have only maybe 3 to 4 minutes. I'm sorry.
Yes.
But we have eaten your time. Okay. Yeah.
Yeah. Okay.
No, ma'am, you are not audible. Your voice isn't clear.
My voice is still not clear?
No, it's good. It's good now. It's good now. It's good now. When you were angry, it was clear.
Okay. Is my PowerPoint visible?
No. Santosh, have you made your slide stop share?
Yes, sir.
Okay.
Now I think you can see.
Yes, we can see your PowerPoint.
So this is a course called as Fundamental of Automation Engineering, which is taught in 2 parts. Part 1 in semester 1 and part 2 in the second semester. In the first part, we teach digital circuits, and here we teach digital logics. Different kind of. We start with simple logic gates. So you are seeing here a logic gate being simulated. And then students, in addition to simulation, they also hardwire these logic circuits on breadboard and verify the truth table. Based on these understanding of logic circuits, then they do project. So you are seeing here a project on music player. Nowadays, we are using most of the equipment which are digital. So this is a digital music player, and it works in different states, like the different states could be play, pause, or unpause. So this user interface has been done using Python programming, and this is called as finite state modeling. They have the students do various projects using finite state model. So you can see here another project where they have designed a FSM model for a microwave oven. Yet another model where you see at airports you find pay restrooms. If somebody wants to use the restroom, they have to pay, and there is no human being there. These are all automatic machines. So this is an interface for a pay restroom. Similarly, when we go on highways, we see there is a fast tag machine. So they have developed a fast tag machine. Along with that, the machine can authenticate the RC, as well as it can check whether the pollution is under control for that particular vehicle. In this way, they have developed some 150 projects in the last 2 years. Some of these are listed on the slide shown here. These projects were all done on Python. In addition to software programming, students in this course, they develop hardware. So you are seeing here is an electronic integrated circuit made over a breadboard. This is a circuit which is used in the lift elevators, where a person presses a button and the elevator displays on which floor it stops. So there is a 7-segment display for that. In the part 2 of this course, students do learn a lot about DC motors and electrical circuits, as well as they make various projects. So you are seeing here the project on bicycle. They made a bike computer here, and the next project which you're seeing here down is a crane or a material movement system which is used at airports and many other applications. They do various projects on embedded systems also. So you are seeing here some microcontroller boards called as MSP430, and some of the projects here are, you can see a RFID tag detector, which is used in a lot of malls where students, where you see that when you go to a mall, you buy something and you cannot go out without removing the RFID tag. 2 more projects are shown here using the same microcontroller. In addition to this, we teach introduction to IoT to all program students, whether he's from mechanical, computer science, or electrical, or any other branch. So we teach them various sensors, boards, and the projects which students have done, some of them are shown here, where you see a conveyor belt. This is a project for detecting fire. Another project on SOS machine, when a person is in danger, it sends the location of the person. Many other projects you can see here. And with this, I will just stop sharing. And I would like to mention that when students do these projects, they do get trained and they take part in innovation competitions. And many of them have won awards. So thank you. With this, I will stop sharing.
Thank you. That was very precise and very sharp. Thank you. Yeah. Now I request Dr. Jaya to tell us about the way we teach mathematics in a very interesting manner, combining it with other engineering, mechanical, civil, electrical, and with programming also. So yeah. So 4 minutes, Jaya. I'm sorry.
Thank you, sir. Am I audible and my screen?
As clear as always.
Okay. Thank you very much, sir. So as Goyal sir already shared, that integration is very important. So although I'm talking about 3 courses of mathematics, these are courses of analysis of structures and systems. Means these are not purely mathematics. We are teaching mathematics, we are learning mathematics by analyzing structures and systems. So I'm talking about calculus and applied mechanics, which we teach in 2nd semester, computational engineering analysis, which we teach in 3rd semester, and computational engineering analysis 2, which we teach in 4th semester. Here I have written the team members to tell you that we teach these courses as a team, not individually. So see, in general, we whenever we talk about mathematics, formulas comes to our mind. But in courses of mathematics at JKLU, we talk about system stability, system analysis, system and structure analysis. So the pictures are in front of you. In the first course, we are talking about stability of bridge or floating bodies. In the second course, we are talking about stability of struts or audio systems, electrical systems. In the third pic, you will be able to see I have shown boilers and complicated electrical systems like amplifier. So it's not that only we are teaching these things, but we are teaching these things in a different manner. So what we have done, we have re-engineered the courses, means we have mixed mathematics, we have integrated mathematics with mechanical, civil, with electrical, to integrate the concepts with their applications then and there. Many a time students learn mathematics, but when they need those concepts, they generally forget and they have to recall them again, or they have to study them again. But in these courses, we are talking about the concepts as well as their applications at the same place. As already explained about the evaluation scheme, so in such courses also we have very dynamic evaluation scheme. So this is the skeleton of these courses. We talk about the physical problems. Students then are able to identify problems. हम उन्हें समझाते हैं कि कैसे आपको रियल लाइफ प्रॉब्लम्स को, engineering problems को formulate करना है, उनकी mathematical modeling करनी है. Then how you need to solve them using mathematical methods, numerical methods, and experimental methods also wherever applicable. And then finally analyze the problems and evaluate the different solutions. So this is about the first course camp. The students build these projects, and while building these projects, while fabricating, while learning about these projects, they learn the concepts of mechanical as well as mathematics. Then, they analyze with different methods, analytical methods, numerical methods, and, testing, labs, everything. So, we are integrating all the concepts which are actually applicable in real life. Merely understanding the formulas and solving a problem on paper doesn't serve our purpose. So this is the second project which students do in the first year in the course Calculus and Applied Mechanics, where they learn the stability analysis of a floating body. So for this, we have very many activities to deliver the required concepts effectively. So I have put some few activities to give you a flavor of what type of activities they do in their class to understand the concepts effectively. They go for fabrication, they go for testing, they go for measurements, they go for their modeling, mathematical modeling, and complete analysis. So these are few picks which will tell you how the students are able to combine, integrate all the concepts. So this is the overall project poster, which will give you some flavor of that, how they are modeling, concept building, their evaluation, and everything. Now it is about the higher semester course, where again they are, they are learning higher concepts of mathematics as well as engineering. So these are engineering concepts which require good input of mathematics. So we have integrated these concepts and we are delivering those concepts in completely integrated manner. So in mathematics course, you can see so much of coding, so much of experimentation, and so much of application to make it more worthwhile.
Okay, ma'am. Sorry to interrupt you, but I would like to ask Sanjay sir that we would like to have an ending meal from your side for our viewers, to whatever guidance you can give by your experience to them.
If you have a specific point on which I should speak, I would prefer that. Otherwise, what I wanted to say, please do not see, you live human life only once. Okay. And it is also uncertain how long would we be able to live our life. It is also uncertain. So living it under the pressure of the society, friends, parents is not the best way to live this. Identify your pain, your passion. That's very, very important. Be engineer by all means. Perfectly fine. Engineer is such a fascinating discipline to be in. Engineering does not just limit you to do engineering. Engineers can become film stars. Engineers can become chief ministers. Engineers can become prime ministers. Engineers can do marketing. Engineers can go to management. Engineers can become IAS. They can become IPS. They do all sorts of things. 70% of the selections in IIMs are of engineers. 70% of the selections in civil services is of engineers. Okay, so engineers are doing marvelous job in all sectors. Art also. They are musicians. So identify your passion area, learn the skills of engineering, learn the knowledge of engineering, and then put it to some very interesting use. If you are excited about sports, welcome. Do some engineering for sports. Make interesting things for sports. If you are interested in music, welcome. Make some interesting things for music. If you are interested in healthcare, well, hospitals and doctors are waiting for your innovations to take better care of the patients. So many people are dying. So many people have died because of various diseases. If you are passionate about healthcare, you are passionate about saving human life, engineering, do collaborate with doctors, make them life easier, make them more effective. So engineering it's like that water that you mix with any other discipline and you discipline with any liquid and it takes that color. So engineering is very, very generic discipline. It can be combined with anything. You want to work in infrastructure, you want to work in music, healthcare, sports. These are unconventional areas. Nobody thinks of these as engineering applications. I'm saying, Olympics benefit a lot from engineers. the Olympics would not be possible but for the engineers today. No big event, no big project in any area is possible without a massive force of engineers today. So engineering is a very bright area to be in. All the engineerings are very good. You identify what particularly excites you, pick that area, learn contemporary skills, and be a global citizen. Don't limit yourself to your city. Do not limit yourself to a state. Do not limit yourself to your country. Be a global citizen and make the whole earth a better, wealthier, prosperous, and safer and environment. Take care of environment. This is what I would say. As an engineer, you can contribute to the environment a lot. The previous generations of the engineers damage the environment. Your generation will improve the environment. That is the challenge. When they were building cars, when they were building factories, they were not mindful of the environment. They did not realize that it can damage the environment, but they did. But your generation will make smart machines which will actually improve the environment, will make this earth a more livable place. And with engineering, you can do anything, I would say. And so live your passion, combine it with your engineering, and live a happy life, prosperous life. That's what I would say. Don't be a person under pressure of society, parents, friends. Don't come under that pressure. Enjoy your life. That's very, very important. Thank you.
So I hope you enjoyed the session a lot. If you are left with any doubts, then you can do comment on the video, and please share this video with all your friends so they also come to know about what are the future of engineering branches in India. It made clear that an engineer can do everything. Only the placement is not the ultimate goal in the college, right? So if you have any doubt, then you can do mention in the comment section. So this is up for the stream. Have a good day, guys. Bye bye.
At the last, we would just like to thank all of you for joining us, all the respected faculties and Sanjay sir. Of course, thank you so much for joining and giving such a great information to our viewers. So yeah, this was our live session today, and we would like to